Hello everyone, thanks for joining. I'm Aditya Gupta and I will work with game development and interactive systems here through GDG community. Today's session is a little different from a typical learn a tool or write some code workshop. Instead of focusing on engines or frameworks, we will be using Unity by the way. We're going to look at why games feel good to play. Things like jumping, landing, movement, impact, and feedback. The small details that players don't consciously notice but immediately feel. We'll look at examples from games like Celeste and Hollow Knight. I'm sure you must have played it. Break down what's happening behind the scenes and then actually implement some of these ideas live. The goal isn't to make a full game, but to understand the design thinking that separates a game that just works from one that feels polished and satisfying. So let's start with the presentation. So as you see, we have Game Juice 101. Let's see, what is exactly game feel? So when we say game feel, we're not really talking about graphics, story, or even mechanics. Game feel is how the game responds to you, how it feels to move, jump, attack, and fail. It's basically the difference between a game that technically works and a game that just feels right. Most players can't explain game feel, but they can instantly tell when it's bad. Why players think they are good at game because they've cheat for them. Here's something funny. Players often think they're really good at a game, but in reality the developer is helping them constantly. Good game feels skilled. It makes players feel skilled even when they're not. This isn't cheating in a bad way, it's just cheating in favor of the player. If games are perfectly fair, most of them would feel awful, right? So we bend the rules slightly, just enough that the player never notices. So yeah, the player's illusion, right? Why they think they are good. See, if we were talking about games, right? When we jump, for example, I'll take an example of Coyote time. So when we jump, we think that yeah, we timed it perfectly, right? We need to get to a platform B from platform A, so we should jump right at the end to get to the platform B. But then it often feels, what do you say, dissatisfying because that's impossible. That's just impossible to do it. We are not perfect humans. Yeah. So going back to why the player thinks they're good. So this is how we help them. We make them feel that it's them who did it, but not us, right? We trick them basically. And players do hate losing control, right? Not losing. So if you say the player fell, right? We want that instead of them blaming the game that the character feels janky, right? We can't jump at the right time, the control feels loose. We don't want that. If the player dies or loses, we want the player to feel that it's their own fault, because then if it's the game's fault, then it's not a good design. So let's talk about the three pillars of game feel. First, we'll come to responsiveness, right? Responsiveness is about how quickly the game reacts to what the player does. If I press jump, I want something to happen immediately, even if the jump itself happens a few frames later, right? So, but we want instant feedback. There should be no delay in it, where the term often latency comes in, right? But this is not latency. Latency is when your controller, your gamepad, is unable to communicate its response to the player. But this is not that. This is something from our side. How does the player feel about that? Then comes forgiveness. Forgiveness is the game quietly helping the player without telling them. This is where we cheat. So the player, it's basically us forgiving them because yeah, they are not perfect, but the game is not supposed to be a competition, right? It's supposed to be something that makes them feel good, that lets them lose. So this is where we forgive the player for making small mistakes. We help them. Then comes clarity. Clarity is about making sure the player understands what just happened. If something goes wrong, the player should know why. If he was not able to jump on time, he should know that it's that specific reason and not something else. For example, anticipation frames, right? So an anticipation frame show you an enemy is about to attack. So the player knows that yeah, they died because the enemy was about to attack them. Squash and stretch show weight and momentum. When we jump, when we fall, it shows momentum, some kind of some action happening on the screen. Screen shake and hit flashes confirm hits. If you play Valorant, whenever you get hit, you feel this kind of vibration. You see corners dimming, you see red lights flashing, and you see that yes, I am being hit, and that is why I died. So game feel ultimately is not about making the games easier, it's just about making the failure feel deserved. When players feel like they're in control, they'll retry a hard section and 10 times and still enjoy it. That's why game feel exists. It's something very minute, something that people don't know it's happening behind the games. Right? Most of the players think that yeah, if we jump, we jump. That's all the game does behind the scene. But that is not it. A lot goes into a single jump. Now that we know why this matters, let's actually build some of these systems. So let's learn about some systems first, and then we'll continue to implement them into a game. Now let's talk about Coyote Time. I already told a bit about it, but Coyote Time essentially is jump forgiveness. So it was inspired by Wile E. Coyote, the person who made this. You can still jump for a few frames after leaving a platform. Well, you will say that, whoa, that's just false, that's just annoying, that's just wrong. But that's where we help the player. If you see the demonstration on the screen, this is one of those popular games, Geometry Dash. I'm sure you must have played it sometime. So if you see, the player falls off the platform but is still able to jump. If this distinction was not there and we lost the ability to jump as soon as we fell off the platform, it will feel very unresponsive. Player will think that the jump button is not working, even though it is. So that's where we help them. We make it so that yeah, it is jumping. And there are few ways to implement it. Of course, there's Coyote Time, there's Coyote Timer, but we'll get to that after I'll just explain the terms. So let's come to input buffer. It's queue pressed inputs, right? What is input buffer? If a player presses jump slightly before landing, the jump should still happen. Again, this is us helping the player. We jumped, we landed, and then we press the space button so that we can jump again. That is how it should normally be. But then what happens if just at right at the frame the player has not touched the ground but is right about there, and the player presses jump because he wants to jump. Now, according to our logic, because the player hasn't touched ground, we can't allow him to jump. Now when the player presses a jump just when he thinks he has hit the ground, and emphasis on when he thinks, he has not yet. So when he hits the ground and he thinks, well, we did not jump, why? I pressed the button, it did not jump. The responses feel bad. It's bad, just bad. So we have to help the player with that. So whenever the player presses the jump, right as he's about to land, we store it. We start a timer that yes, the player has jumped, the player is about to land, and we start a timer and we calculate it. So if the player has jumped at this exact moment, say 2 feet off the ground, we should still jump after he lands. An emphasis on after he lands. It's not that we are allowing him to double jump. We don't do that. We'll just make it so that when he lands, he can jump again. So it's a very important distinction. Let's keep that in mind when we implement it. Let's go to the second slide. Then we come to early and late input windows. Now it is very much similar to say input register, right? Where we store the jump button, the input buffer. But what's the distinction here then? Early and late input windows. This is mainly for say combat or rhythm or actions. It's about if the player is attacking, right? And the player, he's doing a combo and the player ends his first combo, and now he presses the button for the continuation of that combo. Well, we should continue that, right? But what if the combo has ended and then the player presses the combo continuation button? Now the combo will restart and the player will feel, well, that's unresponsive, that's not true, I pressed the button, he'll feel unfair. So that's what we allow it to do. We create a early input window. We press attack slightly before an animation ends. Now, what that allows us to do is, well, the animation did end. We press the continuation combo button just before that, but it will still allow us to continue the combo. We also add late input windows. So when the player presses dodge slightly after the hit frames, well, now what? The boss has hit him or the enemy has hit him. Now he did press the shift button, the button to say dodge or maybe parry, but then he has already been hit. So should we allow him? Should we allow him to dodge? What should we do? That's where this late input window comes in. Even though the player has been hit, we don't allow him to see that. We allow him to continue. We allow him to succeed that dodge. So it is, yes, it is kind of cheating, as I've said previously. And you can see examples of this in like Hollow Knight, in Dark Souls, in rhythm games like Osu, yeah, Guitar Hero. So you can see that in Dark Souls, if we did not have this window, the player would not been like a big fan of Dark Souls because there's a lot of dodging and parry in there. So it's very important to, especially games like Dark Souls and Sekiro. Now we'll come to better jump physics. Okay, so when the player presses the jump, we jump. Cool, that's what we wanted to do. Sure. But then what if it feels still a will you know stale, a bit stale? Although we jumped, we did everything we wanted. We used coyote time, we used input buffer, but the jump still feels stale. Now why does that happen? It ultimately comes down to the physics of it. In real life, obviously, the higher we go when we jump in real life, that's how we come back. The speed is somewhat constant. There's a curve, of course, if you go deeper into physics, but this is not a physics tutorial. So if you go deeper, that happens. But it's somewhat similar. Like if we jump, and that's how we will land. But that can often feel unresponsive. So how do we fix that? What happens there? We increase the gravity when they fall. Now that seems a bit counterintuitive. Like why would we do that? That just makes the jump feel more unfair, right? No, it actually does the opposite. So when we jump, and then during the jump, we shall keep the gravity same, sure, but then we reach the peak of our jump. When we do that, we will come down, and then when we do, we increase the gravity. So now there's weight to the player because ultimately it's a 2D object on a screen. It has nothing of actual physics, but then we want to make it feel real. We want to make it seem like yes, it's a real thing in real world. So what do? We add gravity to it. We add impact frames. So we make it feel that yes, gravity is pushing it down even when it wouldn't. Then to make the feel a bit more, right, what we can add is, not every game has it obviously, but this is something which is variable to your game. So you may either add it, the game may require it, or it may not. Some games like Mario, Super Mario, they use it. So what they do is they use variable jump height. We jump on the press of a button, but then how far do we jump? How do we decide that? Because every time if you press the space button and we jump to the maximum height possible, then what about jumps that require you to, well, not out jump them? What about shorter jumps? What about shorter platforms? What do we do then? That is what allows us to do this. So we press the jump button, and for the duration the jump button is registering on the system. That is how far we'll jump. So we'll press down the button, we'll count the timings of it, we'll count it, we'll start a count. And when we see that yes, we have reached the maximum timer, the maximum jump height of the player, we should stop the jump. This distinction, this if condition is very important, because if we miss this, then the player can jump infinitely high as long as they press the space button. Then it's not a jump, it's basically flying. It's not a Superman game, it's a Mario game. So how we implement it is basically, if it's an upward motion, then gravity is low. If it's falling, then it's high. It's very simple, and this increases the responsiveness of the game and the precision. Let's come to screen shake and hit pause. Now these are not for the player. Like, it's not supposed to make the game easier. It's just supposed to make it feel more impactful. I'll give you an example. Okay. So I'll show you a GIF there. Yeah. So you can see here when the player punches the sandbag, you see the screen shake. It's very minute. Maybe when you're playing it, you might not notice, but since it's right out here, you can see it. The screen wobbles, it goes diagonally left and right, and it happens right at the moment the player hits the sandbag. Now, if it was not there, it would feel rather stale that, yeah, we hit the thing, but what's our reward for it? And this gives us instant feedback that, yes, we hit someone. Now we want some impact. We want to feel good about it. This adds weight to it. This adds weight to the punch. If you punch something in real life, it's not like it just keeps on flying, right? If I punch here my hand, it's not like as soon as I punch it's gonna just float away slowly. That's not gonna happen. You're gonna feel some kind of impact, some kind of vibration. So when I punch this, my hand vibrates, both this hand and this hand. So you can see how that can help, and that is what screen shake is. Now let's come to hit pause. So what is hit pause? Now we did see what is screen shake. At the moment of impact, we shook the screen. But when do we use hit pause? What is time stop? So for a brief moment, a very minute brief moment, we slow down the game time. So if it's going in 1 times the velocity, the speed, we slow it down to say zero point 0.2 or 0.3. So that the impact frame, right? What is the impact frame? It's the moment the hand hits the sandbag. So at just the impact frame, the time slows down. Now we'll see that slowly happening. So we punch it and we see it slowly happen and then it goes back to its normal speed. Now this small timer where the punch is coming, and then slows down and it goes back. This small time, it adds a huge impact. It makes you feel that something big is happening. If you play games like, say, Prince of Persia or Assassin's Creed, at very vital moments, you'll see that when they jump, when they are about to assassinate, something happens and the time slows down. It's very minute, it's very hard to notice. But if you notice, it's there and it's almost invisible to the player's eye, but it does register to their, say, subconscious that, yeah, they felt impact, they felt something happen. And how you can implement it's actually very easy if you're using Unity. So in Unity, you can just, add camera shake, right? We actually don't shake the entire world. We shake the camera because that's easier to do than shake the entire world of the player. So we add a tiny camera shake when jumping or landing, say, for example, or we add a tiny time scale change. So Unity has its time scale, something to keep track of the speed of the entire games. So when you slow it down from 1 to say zero point zero 0.05 or something like that, it actually slows down the entire process. So we'll do that, we'll implement that, we'll see all that. So let's come to dynamic difficulty smoothing. Okay, this is somewhat not very common. We may implement it, we may not implement it, it's not necessary. It really depends on your game. So for example, right, Mario Kart, right? I feel like a lot of players must have played Mario Kart. It's a rather famous game. But if not, you can also see to games like Asphalt, right? There's also Need for Speed. So these racing games often implement this. Say if you are a good player and you start off smooth, so the AI of the enemies, it's the same, right? It's not like we choose the difficulty of racing games. Do we want easy, medium, or hard? We can choose how we control the car. They are like settings to make it difficult to control or hard to control. But ultimately, the enemy AI is same throughout, right? It's not an option for us. So how do they make it so that good players feel good and bad players do not feel bad? They also feel good. How do we do that? So that's where dynamic difficulty smoothing comes in. Say if you started the race and you are a really good player, you hold the first position throughout the game and you enter the last one. Now, if it's set for like a bad player, say the difficulty is set for a bad player, then this will all feel too easy, right? Then there's no fun in the game because, well, there's nothing challenging here. So what do? We increase the engagement by rubber banding. What is rubber banding? So we increase the difficulty of the AI, for example. So now, if we are fast, the enemy is also fast. They are able to dodge the obstacles coming their way. They are able to get some higher power ups in Mario Kart, for example, something like that. Or if we are slow, then we don't want to feel bad about it. So we make the enemies easier. We make them so that they are not able to get the turns right. They are not able to get the good power ups. No, we think that it's luck. Whatever the power ups or the basically the objects that the enemy gets, it's luck. But it's not luck. There's an algorithm about it. So it decides what the player is supposed to get and what the enemy is supposed to get. So how Mario Kart does it is what is very visible to the people who play it is when you are at the last place in Mario Kart, you'll get the really good power ups like the speed boost, the blue shell turtle, right? Things like that. But if you're the first place, you'll get some somewhat okay power ups like those score increaser and all, right? So we dynamically balance that. Even in FPS games, if you not in obviously multiplayer games, we can't do that in multiplayer games. We want to make the game feel fair. But in single player FPS games where we have to shoot and all, we'll see that we often feel that whoa, we are low on HP, we are on 1 HP, what would you we play like a god. We are so amazing, we're so good at it, we are shooting the player, we're shooting the heads of the player, so easy. But then it's actually not. It's not that you think that yeah, I'm on low health and I'm playing somehow better. It's actually the game making it easier for you. You think that wow, maybe I'm good, but no, it's the game. So yeah, this is how it's done. Platformers also do that, but I think it's rather rare in games. Very few of them implement it, but they increase the jump leniency. So if you had to implement it something, it would be a if condition, something like if player fails platform segment 3 times, then increase the coyote time, right? That's how we do it. And then comes post processing. Now this is also a responsive thing. Post processing itself is not much, to be honest. It's just there to increase the visuals of the game, right? Make the bloom, there's settings of bloom, there's settings of vignette, there's so many settings to mess around with, and it makes the game look good. But we can also use it to make the game feel good. Now how do we do that? How can a visual thing do that? So what happens, instead of keeping the vignette to zero point 0.5 for the entire game? So what is a vignette, by the way? It's just like a black bar right at the corners of your screen. So one here and one here, something like that. And it's like a black screen right here. So it focuses the center of the screen to the player and a black border. It's very faded, it's very slight, but it's there. So now what happens if we use it for something other than visual juice? What do we do that? So what we can do is, say if you were in a focus mode, say if you had a power up in the game, it's like a action game, and you got a power up now in ultra focus mode, you're really strong now. So to showcase that, whenever we press the button to say start the focus mode, we'll see the vignettes increase their fade. So now it's further, much further into the player, much further to the center of the game. It can achieve two things. It can make the game feel fair because now the player has extra ability, but the visuals, the game visuals of what is on the screen is also limited now. So it makes the game feel fair. Second thing, it basically conveys that feeling that yes, something has changed, something has happened, there's an impact, there's some juice there. So this is how we do that. We'll also see that in our game. Then it comes the animation parts of it, squash and stretch. What is squash and stretch? So as the term is, so squash, what do we mean by squash, right? In English we mean that yeah, we press something, like if it's a fruit, we squash it so it shrinks down, right? And if we stretch something, say it's a rubber band, right, and we stretch it, it feels long. Now what if we do that, but to the player character? Very weird, right? That's not how humans react. But we're not going for realism. Always remember that. In games, we never go for realism. We want something that is like, what do you say, fantasy. We want the player to feel it. So what we do is, as the say the player jumps, we shorten him. We make it feel that he has shortened from the impact, the focus and the power of that jump. The jump is so strong that it squashed the player, right? Obviously, it's not the real case, but yeah, it squashed the player. And then when he's coming back, then he's coming back with such force, such velocity that he has stretched now. He's long. And of course, we don't do it to a large extent. We can't do that. That will just break the whole game. We do it by a very minute dot decimal amount. So, say if the player height was 1, we make it 1.1 if we want to stretch it, or if it we want to squash it, we make it 0.9. So it's zero point 0.1 value, very much not in focus, very like not very noticeable, but it's there. The player does feel it. Then is anticipation frames. So I've discussed this before, but it's the same as before. As I've said, it's just to indicate to the player that something is about to happen. If you're getting shot from behind in an FPS game, then you will often see that your screen, your crosshair, will show a red bar type thing at the bottom of the crosshair, which means that it's from behind you. So that's anticipation frame. Or in like uh, single player FPS shooters like Far Cry, we see that someone threw a bomb and we see a blinking light, arrow that this is the bomb, that's where the bomb is, and the player needs to dodge that. These are anticipation frames. Or when a player is even about to be attacked in games like Dark Souls and Sekiro, although these games are hard, they make sure they are fair by using anticipation frames. Whenever the boss is about to do a heavy attack, right, he's about to take his sword, a very big sword, he's got about to swing it. So he shows this animation that he's about to swing it, he's gonna take it back, charge it up, and then launch it at us. We feel that. Those are anticipation frames. The player should know at all times that yes, something is about to happen that he should be careful of. We can't make it feel that it came out of nowhere. It has to be there. It has to show its presence, exude its presence. Then it's camera dead zones. This is a very minute one. Uh, Often, like most games implement it, but so it's very minute thing. Although most games implement it, but it's not major thing. But it's basically that the camera shouldn't react to every movement of the player. So, can we just get to the Coyote Time GIF? Yeah. So we'll see here the camera shifts when we jump from one platform to another. But then you notice that it's not constant. It's not like the player is at the center of the camera for every frame. You'll notice that he goes right and he jumps off the screen, and at a specific moment in time, it shifts. So we don't have to keep the player at the center. We can't do that. We shouldn't do that because that will feel a bit monotonic, right? It will feel very weird because camera should not react to every tiny movement. The dead zones in cameras, they prevent this little jitter and motion sickness. So what we can do in platformers, right, is keep the camera still while the player moves inside a small area. So say we'll create two parameters, a huge parameter that is a stage, that yes, this is the stage we are in, so we should cover every inch of this stage, and then a smaller box which is around the player itself. Now, when the camera moves, the player is moving towards the right and he crosses this box. That is when the camera should know that yes, I should also move. Because if it moves with each constant movement, it will feel very motion sicky, right? So, this is all the concepts, all the game juice that we had to cover. Now, maybe you didn't get all of it. That's fine because we will be implementing them. So, it's fine if you don't remember or something. We will go through them, we'll still do it, and we'll implement it live in Unity. So I'll just shift to Unity now. Okay, so here's my editor. This is Unity, and the version is 6.0.60 F1. This is on Windows, and you can try it yourself. We will provide the GitHub repo for this. And so what I've made is two scenes here, a bad and a good one. I know the naming is very uh, curious, right? Like, what could it be? Possibly you couldn't guess. But yeah, as you have guessed. So let's start with the bad one. What do we have right now? So now we see the player. Okay, we can move left and right, we can jump, but as you can see, the jump feels very weird. It's so floaty, right? Like, are we even jumping? It's more like we are flying, almost flying, but then we can't fly because we don't have wings. It's just they're right in between those two bad things. So you can see the entire game, and it sticks to the side as well. Like, you can see when we jump and we keep pressing the right button, it sticks to the side of the platform. Although we have done everything right. So why do you think this happens? Of course, game feel. Now we have done everything right. We have implemented everything. We can jump, we can move, but it just doesn't feel that good. And I'll just go through the components that I have here in my editor. So we have the player itself, obviously. So the player has a sprite to it, and this is a free sprite. You can pick it up from the Unity asset store. So this is our player, and you can see we can move him around. But this is not the actual player. This is the sprite of the player. The actual player is this. So you can see how it's different from the sprite of it. The player is this capsule collider right here, and this is just a sprite for it. So we often make sure that the player is actually different from its sprites. That way we can implement the things we want to, because if we keep it on the same layer, it may often cause glitches and problems that we don't want to encounter. I'll show you the script for it. I have nothing on this. It's just a rigid body 2D, which is all these components are from the Unity add component itself. You can just search it up here, rigid body. Yeah, there we go, 2D body. But of course we can't edit because you already have it. So yeah, we have the rigid body. We have the default values for it. So mass is 1, linear damping something something, angular damping something something, right? So now we should, I'll just get through it again, sorry. Yeah, so we have capsule collider. We have this collider thingy, this green thing. That's the capsule collider. It just basically shows that, yeah, this is the area of a player. This is something that can interact with the world. Because if we remove it, right, I'll just show you what happens. Did you see that? So the player just fell through the ground because he has no real value in the world if you remove the capsule collider. And then I have the player controller script. I'll just open the script and show it first, but before that I'll show you the other values as well. So we all have the grid. This is made using the Unity style palette. So we have used this style palette. It has all the tiles that I've got from the asset store. I can click on anyone and then I can add it to the scene, right? And it'll work perfectly fine because I've done all the setup beforehand. It's very important that we make the setup before we start doing the actual coding part. So I have the ground layer, and this is basically all the layer. This is our ground, this is our blocks and everything. Then we have the props layer, and these don't have a collider because they're just for decoration, and you can see them move here. I've also set the layer for them. So if we go in additional settings and tile map renderer, you see the sorting layer and set to props. I've created this myself. You can add a layer and give it some name, for example, right? So that's how it's done. But yeah, I've already done that. I'll just show you. My bad. I'll just show you what it does. So if you have set it to props, it's at the front. The Because it's a 2D game, right? We can't actually show its 3D part if something is at front or behind. How do we do it? Is basically overlaying an image over the another, and this is what a sorting layer does. So props means the image that is at the right forefront. Ground is our obviously the ground, so it should be behind the props, and then we have the player, and the player should be right between them. So for example, if we look at the layering, yeah, if I go to the props, now we're behind the grass because the prop layer is above the player layer, right? And this is our basic setup. Now I'll show you the good part of the game, right? The good parts. So this is what our end goal should be. Yeah. So we have animation set up for the character so that it feels something, it feels responsive. We are doing something, some action. So we can move right, left. Now you can see how animation itself plays a major role. When we were moving right or left, it didn't feel like much, but now it feels so much satisfying. We see this little wiggle walk of his, and it's actually really cute, and he's doing it, and now we feel satisfaction for just moving left and right. And then if we jump, there's animation jump. Now it's very minute, and I'll exaggerate it later on to show you the full effect of it. But if we jump, the fox does flatten up a bit, and when we land, it stretches a bit. It is not very much noticeable. I will have to freeze the frame and show it frame by frame, but right now it's not possible. So you can just get an idea. I'll later exaggerate those values. So we can jump, we can walk, and you can see the variable jump height. I'll jump as far and as long as I jump. And like I press the space button. So I can go be here, I can just be here, right? And you can feel the impact of the landing, right? See this, like, yeah, there's weight to it. You know why this is happening? Because we have added camera shake. Every time we jump, the camera shakes a bit, and every time we land, the camera shakes a bit. This adds depth to the player, this adds weight to the player. It feels like a object with high mass, that we have the strength, we land with a really huge oomph factor. And we can jump, and we do not get stuck on the sidewalls, we just jump down, right? So I'll get to how to make this. We'll go through each concept one by one, we'll implement it, and then we'll see how it affects our game. I'll now switch to the script that I have prepared for this. Just give me a minute. Yeah. Can we have the script on the screen now? Now you see this player controller, and we have walking speed, we have jumping force, we have ground distance from the player. So in the editor, I forgot to show it to you guys, but in the editor, there was a little red line at the bottom of the player. And that little red line actually indicates if the player is touching the ground. So it's a line that originates from the center of the player to the bottom of the screen. And if that line is touching the ground, that means we are on the ground. And if we are not, then we are not, obviously. And I added a little indicator to the script itself. We messed with gizmos. So what are gizmos? Gizmos are basically a visual representation of our code. So say if we made this value 1.5 or 1.1f starting from the center to the bottom, and yes, we can just flow with it and do our work without a visualization of it, but visualization makes it easier, so that we know that, yeah, if the error is coming because we did not touch the ground, we know because we drew a line that shows that. So I'll go through the script once, and then we can add on to it and make our game really oomph, really nice juicy game. So this is a rigid body 2D. This basically means the physics object, we added that component to our player. This is a move input. I have used this because that's the Unity's input system, the new input system. I'll get to that later on. Then this is the layer mask. So the layer mask is for the ground layer, because our ground had a layer called the ground, obviously. So we need to make sure that when we are checking the line, it's just through the ground only. And it's not like if another enemy comes below us, we register that as a ground. We don't want that. We want only the ground to register as a ground. So we assign it a special layer. It's like a tag. I mean, it's not like a tag. A tag is different object in Unity, but it's like a tag in the English way. And then we have the input action, the new input system that Unity uses. So now we have these functions. Private void start, this function always calls when the game starts. Then we have the awake function. This is similar to start, the only difference being it starts before the start. Yeah, that's a confusing sentence to go through, isn't it? But yeah, it starts before the starts. So it basically triggers all these things before we can trigger this line. Now why do we want that? Because we want the input system to be held by us, so that we can input something before we start the game itself. Now on enable and on disable are basically saying that, yeah, whenever we start the game and this script exists and it's enabled, we perform, then we want to be able to do these actions. It is not really important. You can add these three functions in the start layer itself, and then you can just remove on disable. It's not really important, but it's just good practice to do so, because that way we tell the script when to shut it off and when to turn it on again. Fixed update, it's very similar to update function, and I'll get to the update function. So update function is basically something that runs every frame, right? It runs every frame. And now fixed update runs every fixed frame rate. So this is used because for physics objects, if we add say force to them every second, every frame, then it's a bit wonky. It performs weird things. So we wanted to do it in fixed frame. That way the physics is well and working. Now the logic itself, we have a function is grounded. We create a ray cast. A ray cast is basically the line. So a line that extends from the transform dot position or player's position to a downward direction for a distance of ground distance from player and through ground layer, because that's what we're checking for. And if it hits something in the ground layer, which means the ground, then we are grounded. And if it doesn't, we are not. Then we use this is ground function for a jump. So if we are grounded, then we add force. We jump, and we add force by adding 0f in the x factor, because we don't want to jump like horizontally, we want to jump vertically, right? So we add a jumping force in the y-axis, so upwards, and with the force mode of impulse. Now there are several force mode in Unity. Impulse is the one which sends the force all at once. So there can be continuous force, like apply 1 Newton force every second, that is continuous. But what we want is say 1 Newton all at once, so that the player jumps with a bang. Then we have the move cancel. It's not that important, but we basically set the move input, right? Move input is the value. If it's 1, then you're moving in the x-axis, right side, or if it's -1, you're moving left side, right? How the x-axis work, how the graphs work. So if we have not pressed anything and it's cancelled, then we put it to 0 because we are not moving. We don't want to move. And if we are moving, then we read that value. So we read the input read value, the vector 2 that we are getting, and then move input is equal to move.x. So we are reading the x value of it, because we are only moving in the x-axis. We can't move up and down. We can only jump up and down. And from the fixed update itself, we add the velocity for moving. So we move with the, say it's 1, so it's moving to the right. If it's -1, it's moving to the left. Into the walking speed, whatever our walking speed is, how fast we move. And we set the y-axis to be the same as we already had. So rb.linear-velocity.y means it basically reads the value, the linear velocity in the y-axis of our rigid body, that is our player. And that is our simple player controller. Now let's make it complicated. Let's add some things to it. Let's start with coyote time. So since we don't have a lot of time, it's not going to be a long session. I'll just show it to you one by one. I will not hard code it in right now. But if we go here and we'll add these headers. So this is header for coyote time. So we're adding coyote time right now. And we need two values for it. Now, what are these two values? It's basically coyote time. So the timer, right? How long after we jump can we keep that going? Coyote timer. This is not something we can set, but this is the clock which will start. So this is that timer. Now we have these two variables to help us. So with that, now we can move to the second part of the coyote timer. Coyote timer itself is very easy because it doesn't do a lot of checkings or something. So now we go back to the fixed update, right? But we will need update for this because this is not a physics timer. We don't want to update the timer every other frame. We want it to update every frame. So we add void update that timer, coyote timer. So we check if we are grounded, then the coyote timer has to be reset. So it's equal to the time we want to set it to. So let's, for our convenience right now, let's set it to a high value so that we can actually see it in effect. Say 5. Okay, that's a bit much, I think. Let's go with 1. So 1. And so now that we have set it as the time, So we are resetting, if it's on ground, we are resetting it every frame. It's a bit weird if you look at it, that why aren't we costing performance? But ultimately in a game, it, like on a small scale, this doesn't matter much. This doesn't contribute to the complexity of it. So we see coyote time is equal to coyote time, and then if it's not grounded, so we have jumped. Now we start the coyote timer. So it, coyote timer is equal to coyote timer minus time dot delta time. So every time we have not touching the ground, we are jumping, and we are minusing that time. Now this time, this is something that Unity provides, but delta time is basically the time frame relative to our real world. Because if we compare it to the normal time, time dot time of a game, what happens is that maybe I have a good PC, I can run it at 60 FPS. Someone has a better PC than me, a better computer, and he can run it at 120 FPS. Now the frames are different, which causes the time of the game itself to differ. So if say I had 120 FPS, that time dot delta time would be much, time dot time will be much faster, but time dot delta time maintains that neurality. So it's not unfair to a person who has less frames or more frames. Now that we have checked for the condition that yeah, we are grounded and we want to start the coyote time, we'll now set it in the condition that yeah, when we want to jump, we'll jump if the coyote timer is greater than 0. Correct? So if we go to our jump button, we were checking for grounded, but now we don't need to check for grounded, because for grounded we are already checking the coyote timer. So coyote will take care of that. Now if we check for the coyote timer, not coyote time, make sure you don't get that wrong. So if it's greater than 0, that is when we jump, right? So that is when we jump. And since we have jumped, we need to set the coyote timer to 0 as well, because it's still going on, by the way. Remember that. Even though we are not touching the ground, right? Yeah, we're not touching the ground, but it's still minusing the time. So if we have already jumped, now it does not need to do that. It can reset it to 0. So we'll just add it here, coyote timer equal to 0. You'll just save that, and just go back to Unity now. Let it load. It's loading for now. Yeah. So I'll just share you the Unity screen now. Now it has loaded, and if you go to player and we scroll down to the script, we can see this coyote timer header, because we put that as a header, and then coyote time is equal to 1, because that's the time we want to take. Yeah, so I'll just increase the jump height because we need to get on top of the platform. So I'll just increase it to say 12. Yeah, that okay, that's a really long. Let's set it to 10. Yeah, now I'll just shorten it again, and I want you to pay close attention on what happens. Now we move at the edge, and although we will fall, we will be able to jump. And yeah, there we go. So I'll just show it again. Yeah. So even though we were off the ground, we are not touching the ground, we are off the ground, but we are still able to jump. Now, if you remove that, let's say coyote timer is actually 0 now. Now we go to jump force again, climb. Okay, now we can't jump because coyote timer is point. Yeah, point 1, let's set it to. Yeah. He just went off the screen. Yeah. So now we jump. Yeah, we can't jump. That does not happen. So now we may feel that it's unfair. So that's how we implement coyote timer. Very easy. It's not difficult at all. Now, since we have done that, let's move on to jump buffer, I believe. So what is jump buffer? It's basically us storing an input that, yeah, we want to store an input. We want to do something. So I'll just share the script now and we'll get to it. Yeah. Okay, so I'll share it now. And can we have the script now? Yeah. So now you'll see it here. We have added this new heading, jump buffer and jump buffer time, and of course a timer. It's very similar to Coyote time. So there's not much to change here. I'll just do some rework of the script because we need it to work with Coyote time. Remember that. It's not that we need one on the other. We need both of them. So for that, what we'll do is we'll update the script itself. So let me just do that now. I've added the headings, right? The variables are there. Now I'll go to update. Now I'll just show you a new code which works with that as well. Yeah. Now we got jump buffer timer. And this jump buffer timer, it basically subtracts the time dot delta time every frame. There is no condition for it. It's working every frame. Remember that. And why? I'll just get that to you. Why is that? So for this, we'll add new logic to our jump as well because we need to change that. And if we go back down, there's yeah, jump performed. Okay, yeah, yeah, the jumping force. Yeah. So what we have done now is we have checked two conditions. We have the jump buffer timer and we have the coyote timer, and we check both of them with an and condition. So we need both of them to be true. So obviously we know why the coyote timer. It checks for the ground touch. It checks for the when we are supposed to jump, and then the jump buffer timer. Now what does that mean? Why should it be greater than 0? Because when we jump, it sets it to 0, right? And then it goes on to minus it. Where's start? Yeah, update method. Yeah, it keeps on minusing it. So when we have jumped, it goes back to 0, and then we can say that yeah, we can jump again because it's about to touch the ground. Okay, so I'll have to show that by adding a jump buffer timer. Now, what is that you ask? We'll add another function. Let's add it right here on jump performed. I'll add the suitable code to it. Let me just add it to the starting because we do need it to be on the start. Because on jump performed, right? So on enable, we need to create this. Just wait. If we go to enable, yeah, there we go. We go input action dot player dot jump, right? And we have this jump performed. Okay, we already have jump performed. So in the jump performed itself, right? We are okay. We should first create the void jump for it. I forgot about that. My bad. So we create another variable for this. Sorry, a function for this. Because if we put it all in one, right, it's gonna cause a bit of issue with the physics of it. Because I told you, because physics is very wonky in here. It works in the late update, but it does not work in the normal update. So we're jumping force. I'll remove that for now. So we have this in the jump function, and we call the jump function here. But before that, we'll add a condition here, which is on jump perform. We'll put the jump buffer timer and jump equal to jump buffer time. Okay. So now every time we jump, this called function is called whenever we have performed the jump. So whenever we have performed the jump, we'll put the jump buffer time equal to jump buffer time. So say if we had a jump buffer time of 1 second, so as soon as we jump, it's gonna count down from 1 second, and if it has already reached 0, then we can't jump again. But if it has not, then we can jump again. So I'll just show you now. I'll have to call the jump function, right? So I'll just show you how to do that. If we go to the jump function, yeah, where is the jump function? Yeah. So if we go to the jump function, we'll do it in fixed update because we want the physics to remain stable. Yeah, fixed update. So in fixed update, we'll add a jump, right? So now we can jump if our jump buffer timer is greater than 0 and carry time is greater than 0. Now you'll wonder that, okay, we calling the jump, sure, we are checking the conditions for it, but it's not like we're calling the jump when we press the button, right? It's calling it every time. So won't we jump every frame, every other frame? That is not happening because we are checking in a jump performed. That jump buffer timer is equal to jump buffer time. So if this condition is false, that means we have not pressed the jump button. So this is equal to checking for input. This statement also works dually for checking if you have inputted the button, we have pressed the button. So if we go into the editor, and after this, I'll just show you all the other parts of it as well. All the other things that I've inputted through a script because we don't have much time left. So I'll go to Unity editor now. Yeah. So now if we see, and if we press the, and we'll just increase it for now because we need to see it visually happen, right? We're not going for a perfect game right now. So we just see it visually happen. Yeah. So I press the button here. Okay, I'll just show it to you again. Wait, I'll just pan the camera. Okay, no, I can't. So I'll just, I hope you can hear this, like see this hand. I'll keep it up and I'll show it to you that I'm pressing the button or not. And this is my hand. I'll just show it to you. So now we are in the air, right? And then when we are in the air, while we are coming down, I'll have not touched the floor, but I'll press the button now. And it jumps again. You see the delay right there. So this is to ensure that we have pressed the jump button even before we have landed. So even, yeah, because I've increased the value to a lot extent, we can see that, yeah, it's taking too early, too quick, right? I've pressed the button right now and it's still gonna jump. So that's unfair, right? But we'll tone it down so we'll feel it fair. Let's say 2.2. And then if we jump, I'll press jump, it will not happen. But if I press jump and it's close to the ground, it will jump again. Now to finish it all up, we have implemented two of the mechanics. So I don't think I have time to cover all of them. So I'll just show you the script of the perfected one. Of course, it's not perfect. There's a lot more we can add and a lot more we can do instead. So I'll just go to the script. I'll quickly show it to you so you can see what is happening behind the scenes. And I'll show each of the mechanic that it's actually implementing. Yeah. So now you see my screen. I'll go through it all. This is the player controller polished. I say it's polished, but it can definitely be better. We can add sounds and whatnot. Yeah. So now we have a bool for if it was grounded, header movement for variables related to movement, for coyote time, for jump buffer. Then we got variable jump. We got gravity. Now this is an interesting one. I did not cover it properly in the PPT, but I'll show it to you now. Then we got the ground check. Now for the ground check, what we had done previously was increase that line from the center of the player to the ground. But that may often not be true because the player can be of any length. He can be this tall, he can be this tall. So the value, the ground offset, the ground check distance may not be true for every height of the player. So instead of that, what we do is create a ground offset. Now this offset says that, yeah, this is the player and this is the player's legs. Let's start the line from this to the ground. Then we've got quantities for squash and setch. We've got animations. And I'll show it to you all these things. In the awake, we have component body and all that. And then you see this new line, right? Original scale is equal to transform.locus scale. So we are getting the original scale. The scale by mean, I say the player is 1 meter high, 1 meter tall. So that is the original scale. Now we'll change that because we want that squash and stretch. So on disable all the classic things that we performed before, we've got the update. This is what I did in the update. This part is similar to you guys. Now this is new. We have created a grounded bool. We take the is grounded variable and we check for it. We shake it. Now this shake thing, I'll show it to you in a second, but this shake thing is actually for camera shake. So if we were grounded, right, and now we're getting grounded again. So when we are landing, that's when we're supposed to shake the camera. And I've set it to 2 value. I'll increase it for now so that you guys can see the impact it has. Although it will look a bit weird because excessive values are not well in games. Then we have functions for handling the squash and stretch, for updating the animation, for handling the flip. By flip, it just means if the player sprite is facing the right side and if we press the left button, it should turn and flip to the left side. That way, we don't have to create animations for every side of the player, be it up, down, left, or right. This makes work for the graphic designer easier, right, for the artist. For white flip, it's just basic. We just flip it X value. If it's not, then we true, false. Then we got the update function. We set the speed value. We set the is grounded. We set the velocity of the y-axis so that we can interchange between jumping and all. We maybe cover animation some other day. And we got a fixed update. We got a better. Now this is new. We've got a better gravity function. Move is same. We're doing the same thing. Jump is what I showed you right now. Just add it to squash and shake. So we are adding the squash and shake, the camera shake, and the chapta and this thing, right? Now I'll just increase these values because I want to show the excessiveness of it. So I'll go with 1.5 height, and I'll go with say 6 for the squash. Then for the better gravity, what we're doing is if we are not jumping, then gravity scale is equal to false gravity multiplier. Sorry, if it's less than 0, yeah, if we are coming down, so if you're jumping, if our velocity is greater than 0 because we're jumping, right, so we have to be positive velocity. If you're jumping, then it's normal gravity. But then if you're coming down, so our velocity has gone into negative because we're coming down, it's against the action of our original momentum. Now we add a gravity multiplier, which means we are increasing the gravity, so the player feels weighty. And this is something for the jump cut multiplier so that we know when to stop it as well. And the gravity scale, originally what it should be normally, is 1f. Correct? Now we'll go back to input callbacks. We've got the on move performed, all these classic ones. Then we've got a ground check. Is grounded, we check it. We have done it before as well. We've got a squash. Now this is new. Very simple. Transform.local local scale is equal to the original scale into y into z. Z remains the same because we have a 2D game here. We can't change the z axis because that would frame it out of the actual vision, right? So we change that value by some x, some y, and that we pass beforehand, which we exaggerated, right? And this is the script that handles it. So we have passed the value what we want to change it to. This is how he handles it. We have to lerp from the original one to the scale because we can't instantly change it, right? If we are going from say this value to this value, if we change it instantly, there's no feel to it, there's no animation to it. But if we go slowly and then come back down, that is what we want. That is the whole point of squash and stretch. Then we've got a camera shake. Now for the camera shake, I've used Cinemachine shake because this is the easiest way to do it. I don't think we need to complicate code. And for the gizmo, it's just the line draw method. We don't really need it. It's not important to our code, but it's good visually to see what's happening. So this is our whole code. Now I've exaggerated some values so you guys can again see what we have done. So now I'll just switch it to the window for the Unity screen. Yeah. And we'll go through it. We'll see what we have done and we'll understand that how to do it again, right? If you want to implement it again into say your own game, how would you do it? So here's the screen. Now let's open our good script. And now I'll show you the difference here. There's a lot more difference here that wasn't there in the editor itself. First of all, the script, of course, we have the values, squash, amount, speed, and all that. Now, I've set these values offset and check distance manually because I need to see how big is the player. If we go here, you see this green line. It's very, let me zoom in. Yeah, you see this green line. This indicates that the player is actually grounded right now. If I say move the player up, this will become red. Yeah, that's why we use gizmos to visualize it. So now it's grounded, and we can see that it's grounded. And we can see all these ground layer. We have set the ground layer as ground because that's our ground, obvious as it is. Then for the mass, so this is a very minute setting. I have not changed much here, but I've increased the mass from 1 to 5 because yeah, we have increased our gravity, but we don't want to increase the gravity, like keep a very big value here, right? For the gravity, yeah, 3.5. We don't want it to something great like this 30 something. We want it to be something that is manageable. So instead of increasing the gravity, we increase the mass of the object. That way it keeps it simple. Another thing I did was add a material to it. This is called a physics material. We can add it to our objects, and that's what it's used for. So we can add it to a player, and you can see that yeah, it's there. It can, what it does is basically friction is equal to 0, bounciness is equal to 0. So if you had remember, what we did was when we jumped and say we were right here and we kept pressing the right button, the player stuck to the wall. Now that's because of the friction. But if you move it to 0, it won't. So that's how we fixed that. Friction is very important, and we don't want to keep it on the ground but on the player itself, because that may cause the ground to slip off our enemies or say any other object we have on there, like say a box or something. That is the basic change in the player itself. Now we added a cine machine. This is what I was talking about. This is cine machine. It's very easy. We just add a follow and we track the target, tracking it. So I drag and drop the player transform so it knows who it's tracking. Then we have these values at position, damping, and follow offset. Now position damping is the one which is a very important because that's the one called dead zone. So damping means that yeah, the player has moved by this amount to the right. So should we move the camera? Should we stay where we are? So this is used for damping. If you mess around with these values, you'll find a perfect value that matches your game feel. So it's very important to mess around with these. Don't be hesitant to experiment. It's very important that you experiment. Now this is an empty game object which actually generates the camera shake. So we'll see the camera shake now in person. Yeah, see the camera shake, right? It's heavy. The more we increase it, the weightier our character feels. It's like he's really big, although he's just a small little fox, a cutesy little fox. But because we have increased the camera shake, it feels like it's like an earthquake happening whenever he lands. Nothing to his weight, of course. And even if in jump, we feel the factor, right? And we see the animation, we see the squash and stretch. You see the little flids that happens, right? The blitz. Look at that. This is because we've increased the values of squash and stretch to a higher extent. But if we hadn't, it would feel rather natural, and you can see that yeah, he's about to jump. Any way to feel. Now, for the other parts that we covered in theory, I have not implemented them because they are not really suitable for a platformer. But one thing that I've done is, yeah, volley profile. So this is the post processing. Now I haven't added it so that it happens to a certain point. It's just naturally there. If we actually turned it off, right? If we go to main camera, we go here rendering post processing, we turn it off. You see the difference. This is how our old game looked, and it's fine. There's nothing wrong with it. But say if you're going for a nostalgic feel or something a bit different, you can always turn it on and you can see the difference. There's bloom, there's lighting, there's color effects, there's vignette on the sides, and I'll show you the vignette in a second. Yeah, there we go, vignette. So we can increase the intensity of the vignette, really focus. So now the player is in a very serious zone or something, or we can increase the smoothness of it so that it doesn't feel rounded or square. It looks like an eye now, so that we are looking through an eye. So a lot of effects we can achieve through this. Then we've got a bloom. Now bloom, it's not really actually necessary for a game because we don't have any bloom material, but it's like a shiny effect. Yeah, you see this. Yeah, this shiny effect, this is due to bloom. This is threshold because if you go to 0, every object has a threshold like if it's supposed to shine or not, and that is what it defines. And we can increase the intensity of that, how much it's shining and all. Now obviously this looks bad, we don't want that, so we keep it to a minimum, as much as we actually need. So yeah, I'll cover that originally. And yeah, so I think I've covered all of them. I've covered for the implementation side, right? Let's go through it all. We covered coyote time, jump forgiveness, so we implemented that. We implemented input buffer, right? We implemented we did not implement early late input windows because there's no action in our game, of course. Then we implemented a better jump physics, so we have variable jump, we can jump as long as we press the button. We added screen shake, so whenever we jump and land we see this impact frame, we see the weightiness of our player. Then we had cinemachine to set up our, say, the impulse, the camera shake, and our dead zone. And we added post processing, right? Not exactly at a frame, but just overall. Then we did squash and stretch frames, right? And we did not add anticipation frames because again, there's nothing to be anticipated here. There's no enemy or boss, so it's not a combat game, so it was not necessary to this. Now this is a project, we'll share this with you, and you can go through it all. You can mess with the settings, the values, all the air, move, speed, jump, force, and you can go to the script itself. You can add something of your own, make it as good as you want. And if you do please show it to me somehow. Yeah, tag me or somewhere wherever you upload something. So I'll encourage you guys to focus on this project and try to make this control feel as much, as much interactive and responsive and forgiving as you can, and add new features. Obviously, even I haven't implemented everything, so I want you guys to see what you add. So yeah, that's it for the project. You can get the Unity from the Unity store. In the, like, if you search for Unity, you'll see it pop up. And yeah, that's it for the game dev session. So that is game juice. What we have, what we feel, what we respond to it, that is game juice. We feel the player, we make the player feel, we make it really responsive, we make it forgiving, and all these concepts that we discussed today. So yeah, that's it for game dev. Now we just get to Casa. Yeah, so welcome back. Now if you made it through here, congratulations. That was a lot of theory, that was a lot of something. I'm sure there were points where it was kind of boring, but I would say if you do it practically, you will never feel bored because this is a very interesting topic. So now let's come to the campaign against substance abuse, which is very important. So the growing concern, right? What is substance abuse itself? So substance abuse, encompassing both alcohol and drugs, pose significant threats to individual health, academic success, and overall community well-being. There are a lot of health risks like long-term physical and mental health issues, decreased performance and engagement, social consequences, obviously, like strained relationships and isolation, and legal repercussions, obviously, if we get into trouble after that. So that's that. The dangers of smoking. So smoking is a leading cause of preventable diseases impacting nearly every organ in the body. Respiratory diseases, chronic bronchitis, I can't pronounce these names, but yeah, they are dangerous. Cardiovascular problems, increased risk of heart stroke, and high blood pressure. There's also cancer risk linked to cancers of the throat, mouth, esophagus, and more. There is reduced life expectancy. Smokers typically live 10 years less than non smokers. Now, understanding alcohol abuse, there is liver damage. Alcohol is processed by the liver, and heavy drinking can lead to fatty liver, alcoholic hepatitis, and cirrhosis. There's also brain impairment. Alcohol affects brain function, leading to impaired judgment, memory loss, and coordination issues. There is addiction, the most problematic of all. Regular heavy drinking can result in alcohol dependence and addiction, making it difficult to stop. There are also social and academic issues like relationships. Now, the broader impact of drug abuse, there's neurological damage, there's physical health decline, there is addiction cycle, there's legal and financial ruin because people often end up spending huge amounts of money to get their hands, and it really destroys their financial life. There's also social isolation. It strains the relationships which you have in your life. It's important to embrace a healthy, substance free lifestyle. Now, it can be, of course, hard, but there are things that can help you, like engaging in activities, discovering hobbies, sports, and clubs that enrich your life and provide healthy outlets. There's building strong connections, surrounding yourself with supportive people. It's always important that your peer group is someone who is supportive and optimistic. So they are mentors who uplift you. And obviously, you should practice self care, prioritize your physical and mental well being through exercise, nutrition, and mindfulness. Now, there are a lot of support systems at VIT. There are volunteers which can help you. You can always reach out to them. We have counseling services in VIT. You can always seek professional help. There are health centers, obviously, for medical support and advice for all students. There's also the student welfare department. They'll list you a comprehensive support for student well-being. Yeah, so that's it for the CASA side of it. Thanks for watching till the end, and I'll see you guys in the next one.